Hello all, this is Sushit Shivananda Jankar, a graduate student at Florida Atlantic University. Today I am giving a demo on a programming project titled Finding the Closest Pair of Points using Brute Force and Divide and Conquer algorithms. So this code showcases two approaches for finding the closest pair of points in a set of points on a plane. The first one is the Brute Force algorithm and another one is the Divide and Conquer algorithm. So let's see the structure of the code and how I implemented it. So to start with, I've imported all the required libraries: random for generating random points, time for calculating runtime, and math to compute the distance between the points. So the next function is the generate points function, which takes a single parameter n, which is the input size. So it generates a set of random points with x and y coordinates within the specified range. It also makes sure that the number of generated points matches with the input parameter. The next function is the distance function, which takes two parameters. The first, the points p1 and p2. So it calculates the Euclidean distance between these 2 points, the p1 and p2, using the formula the square root of x1 minus x2 whole square and y1 plus y1 minus y2 whole square. So coming to the first approach, which is the brute force approach. So this function finds the closest pair of points using the brute force approach. So what it does is it iterates through all the pairs of points generated by the generate points function and calculates the distance using the distance function between each pair, and finally returns the pair with the minimum distance. So the second approach is the divide and conquer approach. So this function finds the closest pair using divide and conquer approach. So if the given points are less than 3, it follows the brute force algorithm. Else it divides the whole list of points into two halves, the left and the right, and then the midpoint is calculated. So the functions then calls itself recursively on the left half and the right half. So after obtaining the closest pairs from both of the halves, it combines and determines the minimum distance. So this is why it is called divide and conquer. Then a strip is created and sorted along the y-axis, and then our nested for loop iterates over the strip and finds the distance between the points. So if any of the points have lesser distance than the minimum distance obtained, the minimum distance pair gets updated accordingly. So the next function is the measure runtime function. So this function measures the execution time of both of the algorithms. It takes two parameters, the function and the points. So it calculates the execution time for both brute force and the divide and conquer with the given set of points. In other words, it calculates the time taken for the function to execute, and it returns the result in milliseconds. The main function initializes the list of input ranging from 10,000 to 100,000. So it runs both the algorithms for the predefined set of points I have defined for the testing purpose, and finds the closest pairs along with the execution time taken by each of the two algorithms. So after this, it runs both the algorithms for each of the input sizes defined here, ranging from 10,000 to 100,000, incrementing by 10,000, and it finally prints out the time taken, the average runtime for brute force and average runtime for divide and conquer in milliseconds. So if I run this code, it would take too long to execute since the input size is big. So what I've done is I've created one more file, and I've removed the generate point function since we are not randomly generating points. So I've manually specified my own set of points, and I'm calling both the algorithms. So if I run this code, it should output the minimum set of points using both of the approaches. One is the brute force and the divide and conquer. So as we can see here, it returned the closest points 1, 2 and 2, 1, and the execution time is obviously 0 seconds since the input size is so less. So thank you.